Hi, everyone. So today I want to discuss with you all HashiCorp's policy as code framework, Sentinel. Whether you're completely new to Sentinel or not, if you haven't heard of it before, or maybe you have, maybe you're using it, I hope this presentation can help you get more familiar with the product and its role in our enterprise products. As just mentioned, I'm Chris Marchese. I'm in the engineering lead for Sentinel at HashiCorp. I also work on the framework and also some of its integrations, specifically Terraform Cloud and Enterprise. So let's start with a brief on what Sentinel actually is. Sentinel is HashiCorp's policy as code framework. We actually introduced it here 2 years ago at HashiConf 2017. It enables IT governance in HashiCorp's enterprise products. So you'll see integrations in Terraform Cloud and Enterprise, Console Enterprise, Nomad Enterprise, and Vault Enterprise. So today, I'd like to give everyone here a general tour of the framework. So to help you, which mostly are your practitioners, to give you an idea of the kinds of things Sentinel is designed to solve, how it works with our products, and how you can get started using it today. So what exactly do we mean when we say Sentinel is a policy as code product? In order to better explain this, let's start by building context and discuss a well-established concept of infrastructure as code. Let's give you a foundation on which we can build and make it even more obvious as to why policy as code is necessary when working with IAC at scale. At HashiCorp, we're firm believers of the concept of infrastructure as code. And we like to believe that our products embody the practice. We believe that investing in IAC is necessary for an organization to scale. It can be very rewarding to practitioners of a wide variety of backgrounds. So let's dive a bit more into what we mean here by discussing how IAC helps by versioning your work, providing automation for your workflows, and providing natural documentation for your processes. And while not necessarily the whole of IAC, we believe that these disciplines are at the heart of the concept. So let's start with versioning. Versioning is the foundation of infrastructure as code. It gives you configuration storage with history. It's a practice of using VCS systems such as Git and whatnot to store your configuration data. And then these changes are tracked, right? So the VCS history tells you who made any change, exactly what they changed and when they changed it. It means that a natural audit trail is produced. And this allows for the observation of change to infrastructure over time. A VCS system, while generally designed for developers, turns out to be a great way to ensure systems engineers can keep track of the modifications that they're making, keep them on hand for backups or redeployments, and roll them back if need be. Now, let's move on to automation. The object of automation in IAC is to support a simple deployment workflow to complex infrastructure. Automation is important here because it's really the heart of one of the hearts of IAC. It's really important. It provides value over documentation and manual procedures. And this is accomplished by transferring manual workflows to automated ones. We also aim to execute deployments or changes in a single operation or vastly reduce the amount of operations that are actually required. And this vastly reduces the manual work necessary and also reduces the possibility of human error. Ultimately, automation enables us to deploy at a speed and scale not normally possible with manual work. Extremely complex operations used to take hours, can now take minutes or even seconds, and you can basically repeat that hundreds of thousands of times trivially. Now let's move on to documentation. I think it'd be hard-pressed to think of any organization that's really good with theirs. All too often, workflows are either or may go undocumented and possibly even forgotten altogether because writing good documentation takes time and it's highly susceptible to drift as situation changes. IAC solves this problem by kind of making the source the documentation. This is generally said tongue-in-cheek in the software development world. But it actually works kind of well when you're talking about infrastructure because it reduces or removes the possibility of documentation that may be prone to frequent change, removes that need. It also reduces the risk of divergence from documentation from reality, and it also helps replace documentation when it comes to automation. Every HashiCorp product implements the concept we've just discussed to some degree. As IAC tools at heart, Terraform, Packer, and Vagrant are industry leaders when it comes to provisioning multi-cloud infrastructure, images, or development environments. And while not necessarily IAC tools themselves, Console, Vault, and Nomad are their design makes it easy to version configuration, automate management, and document their particular problem demands. Now that we have some of the background on infrastructure as code, let's take a look at some of the challenges that may arise when applying these principles within large organizations. Now, IAC is great, of course, because it allows you to scale. It reduces the barrier to entry through automation, in addition to just allowing people to do more. But as the organization scales, IAC presents its own challenges. The increase of productivity inherent in automation makes risk management harder. It can put pressure on the teams who are responsible for reducing or managing risk within the organization. And this can make it hard to effectively manage things like security of the infrastructure, ensuring the organization's in compliance, and ensuring your workflows follow best practices. Let's take a look at why these things are important. So let's talk about security. And security is a fundamental and important part of every organization. As an organization scales, though, there's always a risk that security policies and procedures may get lost in the growth. Also, security awareness is subjective from employee to employee. Through no fault of their own, an individual may unintentionally perform an action that could expose the organization's infrastructure to vulnerabilities. Even security awareness training may not account for this, especially when you're talking about good old-fashioned human error. Security lapses at scale, too, can have extremely disastrous results. Your stakes go up as your organization scales. And data breaches at large organizations are usually newsworthy events these days. It can involve millions of users and can cause damage to trust that can take years to repair. And hand in hand with security is compliance. And security and privacy procedures usually take the form of industry-mandated policies. Examples here include, say, the PCI DSS for payment processing, government standards such as FIPS, and also data privacy standards such as the GDPR. Violations of these standards can affect your business in various ways, right? Like PCI DSS, if you violate that, you lose your ability to process payments. Violate FIPS, you lose access to entire business sectors. You violate GDPR and you can face financial penalties. I think like the record right now is 200 million euros. Yeah, pretty nuts. All practitioners need to be aware. They need to receive the appropriate training, but as with security, not everyone's going to have the same level of awareness in general. And as your organization grows, it becomes increasingly harder to manage this at the human level. And finally, there's the concept of best practice. These aren't necessarily hard and fast security policies or privacy standards like the GDPR. These are just generally correct procedures that aren't covered by a specific standard. Examples here include, say, not setting up for a single point of failure, optimizing for cost efficiency, or building for a responsive user experience. But best practice really can be a fallacy as far as I'm concerned. I kind of have a problem with the term because best practice and common sense are just used interchangeably too often. This just leads to assumptions, right? You just kind of easily swap out, it's just best practice with it's just common sense. Where you're trying to convince someone like, to just do it this way, and they might either not understand, and they might have a different perspective on it. And then, when you're dealing with things like a post-mortem, hindsight's always 20/20. It's kind of like, why didn't we do this? Or, why didn't we just do that, right? These problems are aggravated at scale. So as you take on staff, you're actually going to have a lot more opinions on what actually constitutes best practice. So how do we solve these policy issues? How do we make sure that we eliminate the assumption that everyone knows how to set up infrastructure properly, or that it adheres to industry standards and government regulations and doesn't make the organization vulnerable? So let's talk a bit about policy as code. So let's talk about a traditional process first. This is the process of using documentation for manual review. In a manual process, security and compliance best practices are generally stored in documentation. And then these are applied by practitioners during code review or say dry runs, which is like, say, like a Terraform plan or something like that. And generally what we're talking about here is a pull request will come in, code review will happen, someone will look over that and apply the documentation manually. And the issues here are threefold. And first off, code review is a labor and requires context. This would be tough if the domain experts for the code review are on one team, and the experts on security and compliance are on another. Reviews take enough time already, and these kinds of things can exacerbate them. Also, errors can be missed or subjectively accepted as correct. No one reviewer is the same here, and sometimes there can be a number of factors at play too, in addition to just like, context. And finally, review can take days and lead to frustration for the practitioner. This can be a disempowering process and kind of negates the gains that IAC gets you. So this is really why policy as code is important. Moving your policies out of documentation and into code allows you to automate these checks and balances, remove arbitrary interpretation, and provide immediate results for engineers. This all frees up more time for everyone to do the work that they're good at and enjoy doing. Further to that, our policies now enjoy the same benefits as our infrastructure code. You version your policies and store them in VCS with a change history. You automate your policy checks as part of your normal quality assurance process, or your PR process, et cetera. You document your policies with code, and this replaces a good part of your on-paper policy. So let's talk about some of the things we've been trying to do with Sentinel at HashiCorp to help make policy as good, code a good experience for everyone. So our objective when designing Sentinel is to bring infrastructure as code to the governance, risk, and compliance field. And this means bringing over a lot of people that aren't necessarily programmers. As such, we've aimed to design a language that would be both friendly to non-programmers and programmers alike. In addition, we aim for Sentinel to be embeddable, that is easy to integrate in all of our products, safe, so that it can be executed in a sensitive context, and finally, auditable, so it's clear as to why policies passed or failed. So let's elaborate on some of these fundamentals. First off, we aim to design Sentinel in a way that programming experience isn't necessarily required to work with the product. As just mentioned, we're talking about stakeholders here that might not necessarily have a programming background. They might have a more operations-oriented background, or they could be traditional systems engineers, so maybe just scripting background or whatever. As practitioners of Sentinel, we want these audiences to be able to understand policies written in the language and be able to write them to a level of complexity. So we aim to do that by a couple of principles. And the first one is emphasis on simple policies. The language and integrations are extended with the objective of keeping policies short and readable. And in addition, we also keep policies restricted to a single file of code. This ensures that if it actually gets too complex and this policy gets really long, we can kind of do things to rein this back in to keep in line with these principles. And secondly, we use an English-based grammar. Most statements, keywords, and operators are English language words, structured in a way that reads something between pseudocode and regular English language sentences. At the same time, we still aim to make Sentinel friendly to programmers. Stakeholders with programming or even at least scripting experience will be able to write more complex policies than those that don't have a similar background. Sentinel has constructs that a programmer would reasonably expect, such as conditionals, loops, and the ability to create functions with more complex workflows. The Sentinel simulator also has advanced testing and mocking features, and we'll cover those a little later in the presentation. These features allow practitioners to mimic the environments that they'll encounter in production to ensure policies function correctly. And to help with processing the wide variety of data that can be encountered in Sentinel, we also have a growing standard library that we're building on all the time. And some of the imports included in the standard library are things like time import for accessing the time of the day, JSON import for parsing and processing JSON data, strings for string manipulation, and then of course we have a lot more that you can actually view on the Sentinel website. Let's talk a bit more about how we design Sentinel internally to be embeddable and safe in the products it's integrated into. Internally, we design Sentinel with the principle of straightforward integration into HashiCorp products. It's actually embedded directly within the runtimes of Consul, Nomad, and Vault Enterprise. This means that Sentinel has to be efficient and minimize the impact of the request path. And this level of embedding also means it needs to be resilient and safe. So we've designed a broadly read-only language and runtime model, as the intention of Sentinel is to generally analyze data and not change it. We also restricted systems resources, so you can't really use it to crash the system. And then finally, back. We also don't really have any ability to do things like execute arbitrary commands in the runtime and whatnot. And finally, Sentinel is designed to be auditable, so you know what rules passed or failed and why. Trace data is retained for rules, including any subrules and conditionals. Basically anything that triggered a specific result. This data is built naturally as rules are evaluated in a policy. This promotes more granular pattern for policy authoring. We encourage authors to write policies with many smaller rules to take full advantage of auditing functionality. Sentinel's been implemented in every HashiCorp product at varying levels, but it's probably seen its most extensive deployment to date in Terraform Cloud and Enterprise. So let's take a look at each of the implementations, including what policies may look like in each implementation, and some of the features that are offered with Sentinel in each of these products. And here's an example of what a policy looks like in Terraform Cloud and Enterprise. In this example, we use data from a Terraform plan, provided by an import that provides the data, which is aptly named TF plan. This example would traverse all AWS instance resources in the root module and ensure that the instances have tags defined. If a resource doesn't have tags, the policy fails and the run is blocked. Sentinel policy checks in Terraform Cloud and Enterprise run immediately after its plan has been made. In this phase, called the policy check, is sent the plan along with the configuration and any existing previous state. You make a policy based on this data, with the results ultimately determining if the plan can or cannot proceed. You can also use a soft mandatory result to require that a plan proceed only with approval from an organization administrator. And policies are organized in Terraform Cloud and Enterprise by the way of policy sets, which have recently been updated to support a completely VCS-hosted pattern. These function in a similar fashion to workspaces in that policies are ingressed as they're added or modified to the VCS repository. You choose to apply these policies to select workspaces or to the organization as a whole. When a run executes, policies from all applicable sets are collected and sent for execution in the policy check for that run. Which policies are executed, along with each of their enforcement levels, are controlled from within an HCL-based configuration file in the policy set repository. Being able to test your policies before they get deployed to a policy set is an important part of the development process. Testing policies live can be tedious, so we provide the ability to allow you to test policies offline before deployment. And as mentioned, we'll discuss that a little bit more later. An important part of offline testing, though, is the ability to work with mock data. The data that comes from Terraform Cloud and Enterprise is very complex, and mocking each in particular scenario can be really hard without access to the actual data. And to help you ease this, we provide capabilities to generate mock configuration data off of any existing Terraform plan. Whether you need additional data to work off of, or a copy of existing data to account for a certain scenario, mock generation gives you the confidence that you're working with exactly the data that you need to work with. The Sentinel in Terraform Cloud and Enterprise also includes the TF-run import. This import supplies you with access to Terraform Cloud and Enterprise specific data, including specific to the run, workspace, or organization. This allows you to write policies that go beyond the data normally found in the other Terraform imports. This example is our basic policy from before, but we've added a win clause in the rule, using the workspace name from the TF-run import to ensure that it doesn't run on workspaces named in a way that would imply that they're for development. And you can also see here an example of the strings import, which is used to match the suffix here without having to use a regular expression. The TF-run import also exposes data from the newly launched Terraform Cloud and Enterprise cost estimation feature. In this example, we have a policy that ensures that the proposed monthly cost for a workspace always stays under a certain threshold. Additionally, this policy also demonstrates the use of the decimal standard import, which has been designed with the explicit purpose of providing exact precision when processing cost estimation data. And finally, let's discuss some features that we'll be implementing in the Sentinel integration within Terraform Cloud and Enterprise. The next big thing planned is the new imports for Terraform 0.12. The import API will better match the data that's found in the more current versions of Terraform, as opposed to the existing API, which is still structured around old 0.11 data. We'll also be adding first-class resource helpers and matchers to help reduce policy boilerplate. Front and center here are helpers that will allow you to search for resources without having to write that code yourself. And also, we're still working on reducing the burden of workspace management by allowing automatic policy set association with workspaces. Through rules defined on a workspace, policy sets will be automatically associated with workspaces as they're added, or even as the rules change on a policy set itself. Now let's see what a policy looks like in Vault Enterprise. Sentinel support in Vault Enterprise complements the existing ACL system with the addition of two new types of policies. Role governing policies, or RGPs, are tied to particular tokens, identity entities, or identity groups. Endpoint governing policies, or EGPs, are tied to paths instead of tokens. During a specific request in Vault Enterprise, all three policy types are evaluated. It starts with conventional ACLs and then moves on to the Sentinel RGPs and EGPs in that order. The first two policies are only evaluated if the request is authenticated, which means that Sentinel and endpoint policies are the only way to perform checks independent of authentication data. Here, we have an example of an EGP demonstrating the instant invalidation of all tokens that have been created before a specific date. And this be used as a kill switch of sorts in the event of a large-scale compromise to ensure that no old tokens are allowed, buying time for forensic analysis and targeted remediation. Similar measures in the conventional ACL system would require a policy can be modified so it's attached to every affected token, in addition to not being applicable to login or otherwise unauthenticated paths. Now let's move on to Nomad Enterprise. Sentinel policies in Nomad Enterprise allow you to hook into the job management process during operations such as job creation or modification. Access to the full job structure is given, allowing deep introspection into any job configuration file. In addition to this, Nomad Enterprise fully supports soft mandatory policies. Where the appropriate capability is assigned to a user, job submissions that would normally fail can be forced to proceed by supplying this policy override flag in the Nomad CLI or via a similar parameter in a specific API request. Here, we have a policy that ensures that all task groups in a job are using the Docker driver, blocking any other kind of job. This would ultimately mean that anything that would be launched would have to be Docker containers. And finally, we have Console Enterprise. Sentinel in Console Enterprise extends a standard ACL system for the key value store past the standard read, write, and deny policies, allowing full conditional logic and access to the data being written. Here, we have a policy that checks for the key being written to and invalidates the input. So for storing the port, it must be an integer, and for storing the value, it must be a word, so specifically a contiguous series of Unicode characters, digits, and connectors. To close out the discussion today, let's talk about the Sentinel simulator. The simulator packages the entire core runtime into a CLI tool that assists in developing and testing Sentinel policies. Whether you're an existing enterprise customer or a practitioner looking to give Sentinel a try, the simulator is an important part of your workflow. Using the Sentinel simulator, you can try out sample policies with the apply subcommand to see if they pass or fail. Here, we have a simple policy testing the functionality of the time standard import. As the simulator comes with the standard library, it's a convenient way to try out various features so you know how they work in practice. And the simulator wouldn't really be entirely effective if it was just able to utilize the standard library. As such, the simulator has capabilities that allow you to simulate the environment seen in HashiCorp's products. Here we see a basic example that verifies a simulated import. The data is supplied as a static object directly within the JSON configuration file. In addition to being able to supply mocks as static data, the Sentinel simulator also provides the ability to supply mocks as Sentinel code. This allows you to mock data that JSON cannot accurately represent, or other features such as functions. And here's an example utilizing the previously mentioned mock data supplied from Terraform Cloud and Enterprise. We don't show the contents of the mock data file as they're generally pretty large. Instead of the object, though, you can see that the path to the mock data file is supplied. Utilizing this more powerful mocking feature is crucial to the accurate mocking of Terraform data and the entirety of the import. And finally, I'd like to take a little bit more time covering the Sentinel simulator's testing feature. A Sentinel simulator can be used to conduct sophisticated testing comprising of multiple tests across multiple policies in a repository. Here, we've laid out an example repository with 2 policies. Within the repository is a directory named test, and within the test directory are 2 subdirectories, each named for both of the policies. And this is where the tests reside. Here, we have passing and failing test files for both of the policies shown. Each configuration file can not only assert different results for specific rules, but can also contain different configurations for mock data, ensuring that you can test your policies against as many scenarios as needed to be assured that the policies behave as expected. This is the passing test, with the import mocked as expected by the policy, and an assertion that the main rule will return a true result. For a more sophisticated policy, you want to add all your rules in their appropriate assertions. As mentioned, you can mock the data as you see fit for each test case. So this is the failing test, where we've adjusted the mock data in a way that you can now expect the policy to fail, which is reflected in the assertion of false for the main rule. To run the entire test suite, you just run Sentinel test. This will run all the tests for all the policies that are found in the working directory. And being able to test not only against multiple cases, but also multiple policies at once in a single repository is especially useful when working with things such as policy sets in Terraform Cloud and Enterprise. The Sentinel simulator is free and available on the Sentinel website. And it's available to use on all major platforms, including Windows, Mac OS, and Linux. And that's it. We actually have more Sentinel for you at HashiCorp this year. If you want to actually see Terraform's mock generation and feature and a little bit more of a deep dive into testing itself, you can be sure to catch Roger's talk tomorrow in LWB, 2:15 p.m. Otherwise, if you'd like to learn more about Sentinel, you can read all about it on our documentation page at https://docs.hashicorp.com/sentinel. If you'd like to know more at the conference, feel free to come by one of our booths, or you just ask me. And if you're interested in an in-depth demo, you can contact sales at https://www.hashicorp.com/go/sentinel-demo. Again, I'm Chris Marchese, engineering lead for Sentinel, and it's been my pleasure to present this to you today. Thank you very much.